Good morning, class. We are looking at the section graphs of the sine and cosine function. We're going to get graphs of sine and cosine function, then graphs of tangent, cotangent, cosecant, and secant functions, and more graphs, phase shift, sinusoidal curves, fitting. So in this section, we're going to look at y equals a sine omega x by transformation, cosine a equals a cosine omega x by transformation, and then determining the amplitude, the period of sinusoidal functions, graph of sinusoidal functions using key points, finding an equation for a sinusoidal graph. So first, a quick reminder, we have a circle of x squared plus y squared equals r squared, centered at 0, 0, and when r is 1 becomes a unit circle, giving rise to the following formulas: x squared plus y squared equals 1, y represents sine, x represents cosine, and the formulas that you are familiar with. And if we go with a more general case, in this case, we then have to write y over r, but in this case, we have to because r was 1 here for a unit circle, and it's no longer 1. That's why. Fundamental identities. We know x squared plus y squared equals 1, which results in what we call Pythagorean identities. In the meantime, a periodic function repeats its value at regular intervals, and it's 2 pi for sine, cosine, secant, and cosecant, and the period is pi for tangent and cotangent. All functions are odd trigonometric functions except cosine, and with cosine goes secant. Fundamental identities, as it was mentioned, Pythagorean identities, sine squared and cosine squared equals 1, tan squared and 1 is secant squared, 1 and cotangent squared is cosecant squared. Quotient identities, tan is sine over cosine, cotangent is cosine over sine, and reciprocal identities, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. We should know them. Now, graphs of sine and cosine functions. Let's go with the sine function and how we do that. Just as we did in algebra, anytime we started with something new, we ended up using points. So let's see what happens if you want to use points and write the pairs. Start with easy arcs, common arcs that we know the values. For example, 0, we know sine is 0. Pi over 6 or 30 degrees is 1/2. Pi over 4 is square root of 2 over 2. Pi over 3 is square root of 3 over 2. And pi over 2 is 1. And then 5 pi over 6 is really the same as pi over 6 in the second quadrant. Sine is positive, so it's 1/2. Pi is 0. 7 pi over 6. It's the same as pi over 6, but in the third quadrant is negative, so that's negative 1/2. 3 pi over 2 becomes negative 1. 11 pi over 6, again the same as pi over 6 in the fourth quadrant is negative. 2 pi is 0. And so those are the values, and these are the pairs. The point being, if I don't know anything about the function, as far as the graph is concerned, I just plot a bunch of pairs. So this is one pair, this is another one, so on and so forth. So if we plot those pairs, this is the way it looks like. So we do have just one period as we go from 0 to 2 pi, and remember it's going to repeat, so it's going to go indefinitely on both sides. But for now, y equals sine x when x is between 0 and 2 pi, and we can look at this part because we're going to discuss this later on, that we have 4 arcs. This is one part. This is from 0 to pi over 2. And as you can see, it's increasing. And then from pi over 2 to 3 pi over 2 is decreasing. So from pi over 2 to pi, then pi to 3 pi over 2. And then finally, the last piece from 3 pi over 2 to 2 pi. So this is the general shape. As long as you learn that, and you must, then graphing anything involving sine becomes easy. And so we will use the key points, the 4 arcs. We also look at the transformation, but as far as the arcs are concerned, we start with the following key points: 0, 0, pi over 2, 1. At the end of those points, pi 0, 3 pi over 2, negative 1, 2 pi 0. So again, just the arcs we are referring to. This is arc 1. Let's call it. This is arc 2. This is arc 3 in this part. This is the 4th part or the last part. And what is important is that this thing repeats itself. Okay, so one way is to pay attention to 4 arcs. So what do we notice? So again, that's the main part, and then it continues indefinitely in both sides. This thing continues, okay, on both sides. So the domain is all real numbers. We just did 1. This is 1. Complete cycle, okay? But the domain is all real numbers. So the domain is all real numbers. The range goes from, as you can see, the lowest point has y-coordinate -1, the highest 1. Therefore, the range is -1 to 1. As you can see, it's an odd function. So if you connect, for example, this point to the origin and continue the same distance, you end up on a point that belongs to the sine graph. If you pick any point and connect it to the origin and continue with the same distance, just for the sake of argument, if I pick this point, I go the same distance, where this distance is the same as this distance, there will be another point on the graph. That's the meaning of odd. Periodic with t, or period with 2 pi. Sometimes they use p, most of the time they use t. The intercepts, they happen at n pi. The y-intercept at 0. The maximum value is 1. And it happens at these values. And the minimum value is -1. So a lot of information right here. Let's do the same thing to cosine, which means we are going to graph in the same manner using common arcs. For example, at 0, we know cosine to be 1, and that gives us the pair 0, 1. Pi over 3, again, I'm using easy ones, is 1/2. So pi over 3, 1/2. Pi over 2, it's 0. 2 pi over 3. 2 pi over 3 works the same as pi over 3. That means 1/2, but it's in the second quadrant where cosine is negative, so -1/2. Pi is -1. 4 pi over 3 works like pi over 3. That means 1/2, but it's in the third quadrant. It is again negative. 3 pi over 2 is 0. 5 pi over 3 again works like pi over 3, 1/2. In the fourth quadrant is positive. 2 pi, the same as 0, gives you 1. So we are back at that. So we can write those pairs. And if we graph it carefully, it will look like this. And again, we are looking at cosine x between 0 and 2 pi. And so we can look at, again, four pieces, this piece, this piece, this piece, and this piece. The function is decreasing from 0 to pi, and then from pi to 2 pi is increasing. So these are the four arcs I want you to notice. This is also called sinusoidal function, okay? I want you to know cosine is a form of sine anyways, and the key points are as follows. So let's look at those. If you look at this portion, number one, this one, number two, from pi over 2 to pi. This is the third part, and this is the last part, last arc. And we look at the endpoints. So this is 0, 1. This is pi over 2, 0. This is pi negative 1. This is 3 pi over 2, 0. And this is 2 pi 1. 2 pi has the same y coordinate as 0. And it gives us some information about cosine. Remember, this will continue indefinitely on this side and indefinitely on this side. Therefore, the domain is all real numbers. The maximum y coordinate is 1, the minimum is negative 1. So we have the same range as sine. So the range is negative 1, 1. Cosine is an even function. So for example, if you pick anything here, and if you go the same distance here, this distance is the same. That means symmetric with respect to the y-axis. That's the meaning of even function. Or f of minus x equals f of x. Now, it has the same period as the regular sine function t equals 2 pi. And the x-intercepts multiples of pi over 2 as long as they are odd. And these multiples are sometimes written as 2n plus 1 times pi over 2, because 2n plus 1 represents an odd number. So pi over 2 times any odd number gives result for cosine to be 0, a regular cosine, a basic cosine. And as I mentioned, the maximum and the minimum values are here, negative 1 and 1. That gives rise to the range, if you will. Now, let's look at the graphs. We're going to look at them both from the transformational point of view, as well as the four arcs, which I believe makes it a tad easier. All of these properties become simple later on when you practice. So it's really just a matter of practice, and you'll be fine with that. All right, so we want to graph y equals 3 sine x. And again, for now, we're going to use the transformation. So what do we notice? It's important to notice that a sine omega x, this is the general format. A in an absolute value sense is called the amplitude. Omega, we have the formula. Sometimes they use in some texts, they use a sine just bx. And again, I want you to be familiar with that because it really depends on the text. It doesn't matter. It's the coefficient of x which has an effect on the period. And ultimately, whether it gets stretched or otherwise along the x-axis. It's going to get stretched or contracted. With that being the case, we notice that the regular sign, y equals sine x, the basic sine function, t is 2 pi, amplitude is 1, amplitude is the absolute value of a, we're looking at this one, okay? And the period is t equals 2 pi over omega. So y equals sine x, t is 2 pi, amplitude is 1. If you have a sine omega x, something in front of the sine function, something in front of the x, the period will change 2 pi divided by the number in front of x. And as I mentioned, they may say bx, so 2 pi divided by b, again, depending on the text. The amplitude is the absolute value of it. So that's something that we should know. So if we look at the sine x and we know the graph, and again, remember, it continues indefinitely, you really want to be concerned with just one complete cycle. Let me just write this for you. This is one complete cycle. And then you can continue indefinitely on both sides, okay, unless the domain is restricted. So as we look at this question, we notice the only thing that is different than sine is just this number 3. So the amplitude is 3. That means you're going to multiply and stretch this function by a factor of 3, which means the y coordinate. So for the same x coordinate, the y coordinate becomes 3 times larger. So what does it mean? We have exactly the same domain. But what about the range? The range was negative 1 to 1, but now it's negative 3 to 3. So the domain hasn't changed, but the range has. Again, this, if we want to go with the transformation, and again, this thing continues. And so on and so forth, indefinitely. So that's the function y equals 3 sine x. So simply put, that's all we had to do. Stretch it along the y-axis by a factor of 2, vertical stretch. What about minus sine 2x? And again, we remember what is sine x, okay? Sine x simply period is 2 pi, amplitude is 1. But now that we have this, we want to pay attention again if you're interested in finding the amplitude, the period, and so forth. The amplitude would be the absolute value of -1, which makes it 1. And you have to divide 2 pi by 2, which gives you pi as the new period. But we are going to do this by transformation, and we start with sine. Never mind this, we start with sine because this is sine. So there are two things that will happen. This -1 will happen, and this +2. The effect of -1, that is really this one gets multiplied by -1. That means you flip this over with respect to the x-axis. So multiplication by -1 means reflect about the x-axis. So the same thing is reflected. Therefore, 0, 0 remains, but pi over 2, 1 becomes what? Pi over 2, -1. This doesn't change. This one becomes 3 pi over 2, and this one becomes +1. So pay attention to these these two pairs, and see what happens mainly. The rest are pretty obvious. Now, this has the regular period t equals 2 pi, and again, sometimes, again, they call it p, but again, depends on the text. This one we call t, some books p equals 2 pi. However, the next thing is to look at number 2, which means Now we are looking at horizontal compression. It's the other way around, or contraction, if you will, by a factor of 1/2. So this 2 pi in essence divided by 2 becomes a pi. So everything, okay, shrinks along the x-axis, or a horizontal compression. So replace x by 2x means horizontal compression by a factor of 1/2. And so what happens is that this pi over 2 divided by 2 becomes pi over 4. This 3 pi over 2 divided by 2 becomes 3 pi over 4. And we have now the function of y equals minus sine 2x we were looking for. And the result is that the domain hasn't changed, it's all real numbers. The range hasn't changed, it's from -1 to 1. So what has changed? The period. The period is 2 pi divided by 2, which is pi. So this has changed to pi. So the graph flips over with respect to the x-axis. That means reflection about the x-axis. These two results in horizontal compression by a factor of 1/2. So in essence, this moves this way. If you look at, compare basically the main piece of 0 to 2 pi, now 0 to pi. In other words, this is what takes place. All right. We want to graph this one. And again, we remember the basic cosine function, where amplitude again is 1, domain is all real numbers, t equals 2 pi, range is -1 to 1. So let's start with the basic. And what I want to show you again, a complete one, complete cycle. The piece in red is one complete cycle. So two things happen. One of them is this, number 2. One of them is this, number 3. Number 2 will multiply vertically. It will stretch it by a factor of 2. So the y coordinates for the same x coordinates are larger by a factor of 2. For example, this 1 pi -1 becomes pi -2. 2 pi 1 becomes 2 pi 2. 0 1 becomes 0 2. So that's the effect of these two. So 2 cosine x, so multiply by 2. And again, we are looking at the main one. Again, let me show them complete cycle. And take a look at the shape of a complete cycle and notice the difference between this and the sine, okay? The sine starts with 0 0, gets larger, and then is decreasing. Cosine starts with 0 1, and it decreases. So we want to distinguish between the two. So having said that, the next one is number 3. Now, if we replace the x by 3x, that means we have a compression horizontally along the x-axis by a factor of 1/3. So in essence, this 2 pi will shrink to 2 pi divided by 3. So that's the effect of that. And so if we look at this, And specifically, if you look at this one versus this one, the period of 2 pi has changed to 2 pi over 3 as a result of that number. And that means compression along the x-axis, the horizontal axis. And now you have 2 cosine 3x. The domain hasn't changed. The range remains at step 2. This is step 1, step 2, and step 3. So the range remains at negative to positive infinity. The domain is still the same, negative to domain is negative to positive infinity. Range is negative 2 to 2. Range is negative 2 to 2. What has changed is the period which was 2 pi. Now we're going to divide it by 3. So that's the main change. You want to be very careful with that. The domain are real numbers, the range negative 2 to 2. Now, let's discover the relationship between sine and cosine. Every sine can be represented by a cosine function and vice versa, and that's why many times in applications we may use only sine. So sine is the same as cosine of x minus pi over 2. So if you look at y equals cosine x, and y equals x minus pi over 2 means we are shifting it to the right by pi over 2. Let me just that means shift right by pi over 2. So we are going to shift the cosine x, which is the red one, starts. Just look at, again, let me use a different color here. I want to show you the, complete cycle. Just pay attention to the complete cycle. And this complete cycle is going to move by pi over 2, and so this goes here. Okay, and the idea is that it becomes a sine function. Regular sine, y equals sine x, or the basic sine function. So one way to look at this, if graphically we want to prove that using a graphing calculator, we can graph both functions. Take a look. We are going to graph y1 equals sine x, y sub 2 equals cosine of x minus pi over 2. How many graphs do we see? We see only one, and they are identical. Okay, so we are looking at the same function. That's why, again, when it comes to application, in many cases, when it comes to sinusoidal function, they stick with just sine. All right, determine the amplitude and period of sinusoidal function. Y is sine x, the period is 2 pi, meaning it's going to repeat itself after 2 pi, and the amplitude is 1. If we make it a little bit more general, a sine omega x, again, I can't emphasize this enough. Sometimes they use b. Again, I'm going to write that in some text. They may write this as a sine bx. So that b is the same as omega here. This is not w, it's omega. In which case, it has an effect on two things. The period is t equals 2 pi over omega, and the amplitude, which was 1, is no longer 1, but rather the absolute value of a. Amplitude refers to the maximum value of the function in this case. Amplitude, the maximum value, that's why we use the absolute value. So if omega is positive, the amplitude and period of sine and cosine, which is y equals a sine omega x, y equals a cosine omega x. Here's the amplitude, here's the period. So when we have numbers in front of a function in front of the x coordinate, we change two things: the amplitude, that means it has an effect on the maximum minimum as well as the range, and then we also are affecting the period t. For example, y equals -4 cosine 3x. Obviously, the amplitude is the absolute value of this number, which is +4. The period is 2 pi over 3. What about 3 sine 4x? The amplitude is the absolute value of 3, which is 3. And the period is 2 pi over 4. Simplifies 2 pi over 2. Simplify 2 pi over 2. So determining the amplitude and period of sinusoidal functions. Steps for graphing sinusoidal functions. If it's in this form, using key points, determine the amplitude and period. Divide the period into 4 subintervals. Remember, the period is normally 2 pi, in this case 2 pi over omega. Use the endpoints of the subintervals to obtain 5 key points on the graph. Plot the 5 key points and draw a sinusoidal graph to obtain the graph of one cycle. Extend the graph in each direction to make it complete. What do we mean by that? Here's a simple example. If we are looking at a sine function, this is the graph. Cosine function, this is the graph. So we want this point, this point, this point, this one, and this one. For cosine, we want this one, this one, this one, this one, and this one. Those are the points, and we have 4 arcs. 1, 2, 3, 4. 1, 2, 3, 4. That's the idea. So let's make some sense out of this by looking at a couple of examples. We want to graph this instead of transformation using key points first and foremost. And notice the amplitude is 4. So graph y equals 4 cosine 2x, the amplitude is 4. Period is t, or t is 2 pi over omega, or 2 pi over 2, or pi. And the idea is this, again, I'll show you with more details. The idea is that, okay, you know the graph looks like this because looks like this because it's cosine, my apologies. So this would be, the idea is that this would be 0, 1, and now it's going to be 0, 4, right? That's the idea, 0, 4. And therefore, this one, which is 2 pi, comma 4, now it's pi, comma. Those are the endpoints, right? And then we figure out this and this and this by cutting this into 4 equal parts to come up with arc number 1, arc number 2, arc number 3, arc number 4. So that's the idea. Now we are going to divide this by what? By 4, because we have 4 main arcs, 5 key points. 4 arcs, 5 key points. So when we divide this by 4, we get pi over 4. And since there is no phase shift, that means we start from the y-axis, okay? In this case, 0, 4 would be the starting point of the graph. As far as the 4 arcs, this means this one is pi over 4. So we go from 0 to pi over 4, pi over 4 to pi over 2, so on and so forth. So please understand that we, from here to here, we are adding pi over 4. From here to here, we are adding the same thing. From here to here, we are adding the same thing. That's how we get this. So if you can understand how we arrive at this using t equals 2 pi over omega divided by 4, divided by 4. And now this will give us this important points. For example, this one is 0, 4. What is this one? Pi 4, pi over 4, 0. This must be what? Pi over 2, negative 4. This must be 3 pi over 4, 0. And this must be pi 4. So this is what we get. And now I'm going to erase this. And this is one complete cycle according to this and this. And now if we continue indefinitely on both sides. I believe using the key points is the fastest and easiest way to graph sinusoidal functions. Let's look at more examples to get comfortable with this concept. Y equals negative 3 cosine of pi over 4 over x. So first we know that general cosine looking like that, but negative 3, the amplitude, it makes it positive 3, the absolute value. Now pi over 4, we are going to divide the 2 pi by pi over 4 to find the period. 2 pi divided by pi over 4 equals 8, gives us the period. Okay. Now we're going to divide this number by 4 because we want 4 arcs. Divided by 4 gives us 2. And so this one, which results in 0, 8, it's going to go from 0 to 2, 2 to 4, 4 to 6, 6 to 8. I hope everybody understands what's happening. We are looking at the 4 pieces and the endpoints. So for 0, so we have to plug in for 0 to see what we get. And you can plug in 0 here because that's the endpoint. If you plug in 0, you get cosine of 0, which is 1, times negative 3 gives you negative 3. I want to make sure I'm going to show you that so you see if I want this one cosine of 0 is minus 3 cosine of 0, which is minus 3, because cosine of 0 is 1. Now, if I want the next number is 2, remember I want 2, I want 4, I want 6, I want 8. So I want cosine of a 2, I get minus 3 cosine of a power 4 times a 2, or minus 3 cosine power 2, which is 0, times negative 3 becomes 0. So that means, for example, here we have 0, 0, and here we get, my apologies, 0, minus 3, 0, minus 3. And over here we get 2, 0. Let's do one more. So we did a 2. Let's do 4 with a different color. So if I want to look at 4, so y equals minus 3 cosine of a power 4 times 4, which is minus 3 cosine of a pi. Now cosine of a pi is negative 1. This becomes positive 3. What does this mean? The following pair, we are looking at 4, comma 3. So I hope everybody can see what we are doing. All you have to do, plug in the endpoints 0, 2, 4, 6, 8 into the equation y equals negative 3 cosine power 4x. So plug in all these endpoints here and evaluate the pairs and draw those pairs. So I did this one for you, I did this one for you, I did this one. You can imagine if you plug in 6 here, what happens? 6 over 4, 3 halves, pi cosine is 0. If you plug in 8, 8 divided by 4 is 2 pi. 2 pi cosine of 2 pi is the same as 0, which is 1. 1 times negative 3 makes it negative 3. And so the graph looks like this. I hope everybody is fine. Again, let me show you the main cycle or complete cycle. This is one complete cycle. And then you continue indefinitely from there on both sides. As you can see, for example, 0, minus 3 is here. 2, 0 is here. And one way is to graph this by writing 0 to 8. So just going like this. This is 0. This is 8, and cut this into 4 equal parts. So this is 4, 2, 6, and then do your graph and the fix. First one is negative 3, 0, and take it from there. So it looks something like that. That's one complete cycle. You can do that by hand and then look at the more detailed graph. Let me show you another example involving sine, so see how it works, and we take it from there. All right, we want to graph y equals 5 sine 3x. And again, we're going to go through the same process of using the key points, noticing that the amplitude is 5. Absolute value of 5 is 5. And the period is 2 pi divided by 3. So now, using the key points, we have to cut Okay, in other words, if I were to, just for the sake of argument, if I were to, so this is 0 and this is 2 pi over 3, okay? And now I'm going to cut this into 4 parts. So that means if I divide this by 4, I get pi over 6. So if that's the case, so this must be pi over 6. Then I'm going to add another pi over 6 to that, becomes 2 pi over 6 or pi over 3. And then I'm going to add another pi over 6. So I'm going to add pi over 3 and pi over 6. And I assume everybody can see it's pi over 2. So we get pi over 2 and then 2 pi over 3. Now, starting with 0, plug in 0 here. Sine of 0 is 0. 5 times that is 0. Let's do pi over 6. I'm going to do a couple of them. So pi over 6. So y equals 5 sine of 3 times pi over 6, right? Which means 5 sine 3 times pi over 6 is pi over 2, and that makes it 1. 5 times 1 is 5. Okay, so you can figure all of them. So we got 0, we got pi over 6. Let's do pi over 3. Y is 5 sine 3 times pi over 3, which means 5 sine pi is 0, so 5 times that is 0. So what does it mean, just for the sake of argument? Okay, so 0 means 0, right? So we have a 0, 0. This means what? We have pi over 6, 5. So let's assume this is 5. That's what it means. Let's do pi over 3. We said it's 0. So pi over 3, let's write down pi over 3, comma 0. All right. Now, let's do pi over 2 also, just in case. If I do pi over 2, then y equals 5 sine over 3 times pi over 2, which is sine of 3 pi over 2, which is negative 1. 5 times that is negative 5. So we have pi over 2 negative 5. Let's assume this is negative 5, so pi over 2 negative 5. And if you calculate 2 pi over 3, you get 0, so it will look something like this. So I hope you see that. I want to actually quickly erase this, but let me just show you the pairs that I just calculated, some of them. I've calculated some of these pairs, okay? So it looks like that, okay? Now, of course, I'm going to show you a better graph. That's really the concept. So it looks like that. And then you continue indefinitely on both sides. So using key points, I believe it makes it much easier. Let's look at this example using the key points. Now, what really is important to understand that since we have a negative sign here, since we have a negative sign here, it's really not a good idea to have a negative sign. So you have to figure out what happens here. You have to take it out. If it's an even function, this goes away. For example, if this was cosine, this negative makes no difference. Since it's a sine, it comes out. That's the first thing you want to do because it's an odd function. You don't want to have a negative sign. Now you say the amplitude is the absolute value of that, which is 2. And the period is 2 pi divided by pi over 2, resulting in number 4. So what this means now, this is 4. We're going to cut it into 4 pieces. 1. So that means we go from 0 to 1, 1 to 2, 2, 3 to 3, 3 to 4. That's the meaning of it. So I hope you understand how easy this becomes. And so all you have to do, plug in this. Now we're going to use this one. Let me use a different color. We're going to use this one. And we're going to plug in 0, 1, 2, so on and so forth. So for example, if I plug in 0, I get minus 2 sine of 0, which is 0. And therefore it gives me 0, 0. And I have this point, just as an example. If I plug in 1, gives me negative 2 sine of pi over 2, which is 1. Negative 2 times 1 is negative 2. And I have 1 comma negative 2. Let's assume this would be the point 1 comma negative 2. If I plug in 2, I get minus 2 sine of pi over 2 times 2. That means pi. Sine of pi is 0 times negative 2 is 0. And so we have 0. If I plug in 3, I get minus 2 sine of pi over 2 times 3 is 3 pi over 2. Sine of 3 pi over 2 is negative 1 times negative 2 makes it positive 2. So we get like 3, 2. And then if I plug in 4, I hope you realize it gives you 0. So it gives you 0 and it'll look like this. Remember, we plug it into negative 2. So let me put it asterisk. We put it in here. And that's it. And we're done. So we get the following pairs: 0, 0, 1, negative 2, 2, 0, 3, 2, 4, 0. And I'm going to clean up. So this is one complete cycle. And this one continues indefinitely on both sides. Okay, so using key points. Here's another example using key points. So what we are going to do, when we come across a case where we have a vertical shift, that means whenever we finish this, this takes it up and down. By how many? Whatever this number is, negative 2. So when you graph this, you have to take it down by 2 points, or you can actually plot the pairs. It's not a big deal. So let's discuss the amplitude is absolute value of -4, which makes it 4. And the period is 2 pi divided by pi, which makes it 2. Okay. And then we're going to divide the 2 by 4, giving us 1/2, which means, just for the sake of argument, if I were to look at that graph, okay, let me just, actually, it's a different color. So we go all the way to number 2. This is the period, and we're going to cut it in 4 pieces. This is 1, 1/2, 3/2. Okay, and so we go from 0 to 1/2, 1/2 to 1, 1 to 3/2, 3/2 to 2. So that's what we do. And now you're going to plug in 0, just for the sake of argument. If we look at this and we plug in 0, so 0 gives us -4. Cosine of 0 is 1. 1 times -4 gives you -4. So just right then and there, let's assume this is 0, -4. If I plug in 1/2, I get -4. Cosine of power 2 is 0, so I get 0. That means I'm here. If I plug in 1, I get -4. Cosine of pi is -1 times -4 makes it +4. So let's assume this is 4. So I'm here. And you can continue with these dots. If you plug in 3/2, you get -4 cosine of 3/2 pi, which is 0. So you get 3/2, 0. And if you plug in 2, just like a 0, you get -4. Looks something like that. This would be the graph of this function. Now, -2 means what? Means every point comes down by 2. So 0 - 4 now becomes 0 - 6. 1/2 0 becomes 1/2 -2. So all of these y coordinates go down by 2. Okay, so I'm going to just, so this goes to -6, this goes to -2, this goes to 2, this goes to -2, this goes to -6. Okay, that's the concept. So let's quickly do that. So we get this one, and then shift down by 2 units. There you have it. Or just like I said, all you have to do, just write the new pairs. Write down 0, -6, 1/2, -2, and the rest of it. Very straightforward. You want to find an equation for the graph shown and look at the period. So what you want to notice is that this is located at 0, 3. This is located at 1/2, -3. This is located at 1, 3. So you have a graph that involves cosine, because we remember the shape. So A cosine omega. So the amplitude, because this is normally 0, 1, the amplitude must be 3. The period is 2 pi normally, but now the period is 1. T is 2 pi over omega. Period is 1 instead of 2 pi. So if 2 pi over omega is 1, then omega must be 2 pi over 1, or 2 pi. So replace the A, replace the omega, and there you have it. A is 3, omega is 2 pi. I hope everybody's clear how we arrived at that. So I'm going to quickly recap. First, I notice is a cosine function, and I put those 3 important points. This tells me the amplitude is 3. Then I notice the period is different than 2 pi. So I make a note of it. The period is 1. And I remember the formula 2 pi over omega makes t, and 2 pi omega in this case is 1. So that calculates the omega for us. Let's look at another example. So again, let's plug in the important points, those 4 points, and we notice a complete cycle looks like a sine function, and obviously the amplitude is the 2, okay, or the absolute value of -2. So notice all of those numbers. Notice all of those numbers. So we use the sine, and it's a reflection over the x-axis. Remember, the sine is looking like that, everybody. This looks similar to that. So it's obviously has flipped over with the amplitude of -2. Okay. Now let's look at the period. The period is normally 2 pi, but over here the period is 4. The period is 4, everybody. Therefore, 2 pi over omega is 4, and omega is 2 pi over 4. Or pi over 2. And we have the formula a sine omega x. A is replaced with -2. A is replaced with -2 because it has flipped over. And omega with pi over 2. So to recap in short, if you want to graph sinusoidal functions using 4 arcs, remember, normally the period is 2 pi divided by 4, which gives you 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi. For sine, looking like this is for a regular or basic sine function having 1, 2, 3, 4, 5 key points. Regular or basic cosine function, 1, 2, 3, 4, 5 points. And again, the arcs are 1, 2, 3, 4. So you want to distinguish among those.